Okay, so first of all, I want you to notice we're here, which means we're 2 lessons away from finishing this chapter, which means we got a test coming up. So today is Wednesday. On Friday, we're actually going to wrap up this chapter. We won't be learning anything new from this chapter after Friday. Next week, I'll see you on Tuesday and Thursday. We'll be reviewing for the test on both of those days, and the test will be the following Monday. So it's about a week and a half away. Okay. I'm going to get you good and ready during the review. For this first test, we will give you a practice test that is the exact same thing as the actual test, just with different numbers. Okay. So you will know next Tuesday exactly what the test looks like, the types of problems that are going to be on it. Of course, the problems you'll see on your actual test will be different problems, right? But the types of problems you'll be familiar with. And then there will be a review assignment as well. So, that said, let's get after it. So today's learning targets, we're going to define a function, and the main thing I need you to walk out of here today is if I give you a situation or a table or a graph, I need you to be able to answer the question, is it a function? That's our big question today. Is it a function? So you've heard that word a lot, especially in the last lesson when we were talking about function notation. But I haven't defined for you yet exactly what it means to be a function, and that's what we're going to learn today. Okay. So let's get into it. Could you guys please find 1.2.4 in your packets? Hello. Thank you. Gotcha. Let me get to the right place here. All right. So this is the lesson where we've got a lot of reading to do. And this is really important. This first problem here, if you guys will pay attention as we read through this story, the definition of a function is hidden inside of this story. So if you really pay attention here and try and get an idea of what's going on in the story and be able to answer these questions at the end of each paragraph, that's going to lead us into you understanding what a function is. Okay? And it's going to be much easier to understand it in terms of this story than it is if I were to just tell you what a function is right now. When we read in this class, I like to read aloud. And how this will work is I'll take a volunteer for someone to go first. If nobody volunteers, then I'll just randomly call on somebody. And then I only need you to read like one sentence. If you want to do two, I'm not going to stop you, but I don't want you to read more than 2 sentences. Okay, once you've read your 1 or 2 sentences, then you're going to call on somebody else in the room to read. If you don't know the name of the person that you're calling on, you can just point at them and say, your turn. Okay, now I do understand that sometimes people don't feel comfortable reading out loud. Maybe you don't like to do it all the time, or maybe just today is not a good day for you to do that. So it's okay if you get called on to say pass. That's all right. Okay. I like when we do pick people to read, like the next person to read, I'd like us to pick somebody who has not read aloud yet. All right. So we're going to go through this and go ahead and start reading. Does anybody willing to be brave and volunteer to read our first sentence here? Up the cola machine. Please. You're awesome. Thank you so much. Go ahead and start with the cola. You can stop at that. You can either read 1 sentence or 2 sentences. Your choice. We're still in the middle of a sentence here. That's a comma. Do you want to keep going or you want to pass it off? Okay, thank you. Okay. Thank you so much. I appreciate that. And I'm going to have you call on somebody in a moment here to read the next part. But let's make sure we understand what's going on here, because Again, this is what's going to help us understand what a function is. So we got a cola machine. I'm going to go ahead and draw this thing over here. You can if you want. I like to have a visual representation sometimes. And there's some different types of soda in it. There's this stuff called blast. How many buttons on the machine are going to give us a blast? How many buttons are there for your blast? I'm seeing there are 2 buttons for blast. Have you guys ever seen this? Sometimes when you go to a vending machine, sometimes they have like, if it's a Coca-Cola vending machine, they'll have like 2 buttons that have Coca-Cola in it because it's a popular thing. All right, so we've got blast and 2 buttons, but then there's some other stuff. There's slurp, and it sounds like there's just 1 button for slurp. Is that how you guys read that too? 1 button for slurp. There's 1 button for, what is it, lemon twister. And then there's a button for diet slurp. So 5 buttons total. What the heck does this have to do with algebra 1, right? We're going to get there. We're going to get there. Okay. So it says, the part A says, describe the input and output of this soda machine. So what are you doing for your input to the soda machine? When you go up to a soda machine, what do you do to the machine? Mm-hmm. You put money in it, and there's something else you got to do too. You got to push a button. So the input is money, and more importantly for this problem is push a button. And what is the output? What does the soda machine put out? Soda. All right, any questions so far? Caden, I appreciate you volunteering to go first. Can you go ahead and pick someone to read next? Dawson. You willing? Hey, Dawson, you're going to start here at while, and you can either end at this first sentence, or if you're feeling up to it, you can read the next sentence too. Your call.
While buying a soda, Mrs. or Miss Whitney pushed the button for lemon twister and got a can of lemon twister. Later, she went back to the same machine, but this time pushing the lemon twister button got her a can of blast. Is the machine functioning consistently? Why or why not?
That's fantastic. Dawson, you went above and beyond. Thank you for that. I appreciate it. All right. So I'm going to diagram this out too. So this is Mrs. Whitney, and we're going to do this. We do this a lot in math when we're talking about functions. We're going to make these little arrow diagrams, and the arrow diagrams show what's the input over here and what's the output over here. So what was Miss Whitney's input the first time around? She pushed the lemon twister button. And what was the output when she pushed that lemon twister button? The first time around, she got lemon twister out. And then she went back later. Did her input change? She was still pushing lemon twister. So same input. Did the output change? Yeah, she got blast instead. So this is the key question here, and I want to make sure that we understand the important vocabulary word here. Can somebody tell me what consistent means? What does it mean to be consistent? How would you define it?
Like doing, for example, doing something repeatedly over and over again.
Over and over again is key, yes. What else would you say about consistent? No mistakes, okay. What else? Any other definitions? Many of you in here are very consistent about bringing your assignments in complete. So to be consistent means regularly, always or almost always, you're doing the same thing over and over again. So the question is this machine functioning consistent? Is it being consistent? I'd say it's not consistent. All right. All right, we're going to go on and read about brandy next. Dawson, would you mind picking someone to read at least one sentence here? Michael, you willing? Same thing, and you can stop after one or keep going, your choice. Thank you, Michael. All right, let's diagram this out. Can you guys go ahead and draw me some arrow diagrams for this too, please? Brandy came along, and what was Brandy's input? Blast. And I'm going to write blast 1 because there's 2 blast buttons. So she pushed the number 1 button for blast, and her output was blast. And then Miguel comes along, and he's going to be different, go his own way. He's also going to push the blast button, but he's pushing the other blast button. And what was his output? Blast. Is this part of the machine functioning consistently? Is it behaving the way you would expect it to? What do you think? Yeah? No? Not enough information? I'm seeing a lot of people nodding their heads, so we'll go with consistent. All right, we got one more person to read about, 2 more people, Lutfi and Taisha. Michael, can you pick someone to start us off with Lutfi and Taisha? All right, excellent. Thank you for that, Tom. Okay, so let's diagram this out. We've got 2 people, and they should be the same, right? Because Taisha, you said notice that everybody who did. So what was the input that she saw everybody doing? The input for this was slurp or lemon twister? Input was slurp. And every time someone pushes the slurp button, they get what? They get slurp? That'd be nice. But they're all getting lemon twister. This is the tricky one. Is this machine functioning consistently? Now, before we answer that, I want to ask you a different question. Is the machine functioning correctly? No, definitely not. When you push slurp, you expect to get slurp. But correct is different from consistent, right? You can do something consistently and do it consistently wrong. So my question about this one, is this part of the machine functioning consistently? And I'd say this one is consistent. Okay, so I want you to think back on what we just saw. So in the first situation, we had people pushing the same button. So instead of talking about buttons, let's talk about inputs and outputs, because this is how we're going to define functions. So we had 2 different people with the same input, but the outputs were different. We said that was not consistent. And the second one, we had 2 different inputs, but the output was the same. We said that one was consistent. In the third one, we had 2 different inputs. No, I'm sorry, the same input. We were always getting the same output. We said that one was consistent. So our definition of a function is really kind of like this, this idea of soda machines being consistent or not. I would say that this machine here is not a function. It is not behaving like a function. This one is a function. And this one is also a function. So does anybody want to try and make up a rule for me about inputs and outputs? If you were looking at inputs and outputs, how can you tell if something is a function? Or I think probably easier to answer is how can you tell if something is not a function when you look at its inputs and outputs? Anybody want to give it a shot? Be bold. Be brave. I want you guys to think about this and then turn and talk to the person sitting near you and tell them what you think. If you had to make up a rule right now, knowing just these three examples and which one's a function and which one's not, and I would like you to come up with a rule that says something about inputs and outputs, whether something's a function or not. Talk to somebody sitting near you, see what they think. Learning this right now, so it's okay. If you give me a rule and it's totally not correct, that's fine. That's fine. This is called making a hypothesis or a conjecture. And it's a really important part of math. Make your best guess. Anybody want to give me a conjecture? All right. That's fine. We'll come back to that. Let's go ahead and look at some more examples. And if we can look at these examples and tell whether it's a function or not, then that may help us make our definition. Okay, so we're going to look at number 63 down here, and I want you to be thinking about this in terms of inputs and outputs. So can you guys squeeze in here input and output? So this is kind of like a vending machine. This one looks like it has some kind of candy in it, and the buttons are just numbered. So I want you to look down through this table and tell me, do you think that this thing is behaving more like the first situation that we talked about? Or is it behaving more like the last two situations that we talked about just a moment ago? Do you think it's not a function, or do you think it is a function? You think not? Let's do a quick thumbs up or thumbs down vote. And this is just your gut feeling right now. You're not committed to this, okay? So is a function would be thumbs up. Thumbs down is not a function. See, mostly thumbs down. Okay, it is not a function. It is not a function. Can somebody point out, there's a specific problem going on here, and I'm curious if you can spot where the problem is that makes it not a function. Zone, what do you think? Can you talk to me about the input first? All right, so you're looking at this input of 2 and this input of 2. Is that what you're going to point out as well? If you keyed in on this and this, that's the key part here that makes this not a function. We've got a situation where we're giving the same input, but we're getting two different outputs. Same input, two different outputs. Do you see how that's very similar to what happened up here in our first situation? We had the same input, but we were getting two different outputs. That's what makes this not a function. Now this next one isn't a vending machine at all. This is where we're turning this kind of more mathematical. Again, I want you to think of this as inputs and outputs. Scan down through those numbers and see what you think about this one. Is this a function, yes or no? All right, I'm looking for your gut feeling here. Thumbs up or thumbs down? What do you think? Function or not a function? I'm hoping we get a mix of both. All right, so I think it's easier to talk about when something's not a function. I'm not saying what's right or wrong. A couple of you voted for not a function. Would anybody willing to explain why you think it is not a function? Thank you. Okay, so you're looking at 0 and 4. And the 6 and the 0. Okay, so we've got the 0 is an input, has an output of 4, and the 6 is an input, it has an output of 0. So is it the zeros that's repeated that you're seeing? Okay, that's actually okay. That's okay. So it's okay to have a number that appears in both the input and the output column. That's actually okay. Now, I'm still not saying it's definitely a function or not. Are you sticking with not a function, or you want to change? You're going to stick with it. Good for you. Anybody else want to explain why it's not a function? Okay. Well, this one actually is a function. This one is a function. We don't have the same situation on this one that we had in the last one. In the last one, the thing that made this not a function is I had an input that was repeated, but there were two different outputs for that input. When I look at my inputs here, I don't see anything that's being repeated. So we have no problems. All right, let's look at the last one. Again, think about inputs and outputs. It's got X and Y. But think about it as inputs and outputs. And tell me, do you see any issues here? Anything that's going to make this not a function? I'm going to call on you in just a second. I want to get everybody's gut feeling first. Thumbs up or thumbs down? What do you think? This last one, function or not a function? Lots of thumbs down this time. Michael, would you like to tell us why you think it's not a function? Mm-hmm. Oh, I was so hoping that somebody would say that. Yes! You're awesome. Thank you. This is my favorite mistake of the day. And it's a mistake, but that's okay, because that's how we learn. Fantastic. Thank you, thank you, thank you. Okay. This is a very, very common mistake, so I want you guys to pay close attention. Is it a problem if we have the same outputs with two different inputs? Is that an issue? I want to go back to our soda machine. Is it a problem if we have the same output with two different inputs? Is that a problem? We can still be a function if you have the same output with two different inputs. So that's actually that's actually okay. That's fine. What we really have to focus is when you have the same input with two different outputs. Oh, I'm so happy. Thank you so much for that. So this 4 and this 4, that's not an issue. That's not an issue. Scan through the inputs and see if you see any inputs that are repeated. Do you see any of the inputs that are repeated in this one? What input is repeated here? Mm-hmm. The 2 is repeated. Focus on the columns with the 2, or the rows with the 2s. We've got the same input here. Are the outputs being consistent for that input of 2? So if I walked up to this machine and I hit the number 2 button, am I going to know for sure what I'm getting out of this machine? No, it could give me a 9 or it could give me a -8. So this is not a function. All right, are we starting to kind of get an idea of what a function is? Okay, let's go on to the next page, and down at the bottom, it's got some space for us to define what a function is. And to define what a function is, we're going to just use the function rule. And here's the rule for functions. The rule for function is the same input cannot give. Would somebody like to finish that sentence for me? The same input cannot give different outputs. Was that what you were going to say too? Awesome. The same input cannot give different outputs. I'm having trouble spelling today. That's terrible. The same input cannot give different outputs. And a lot of times when we're talking about inputs and outputs in this class, we're going to be talking about X and Y. So we're going to go up to the top of the page, and I want you, there's a table up at the top of the page. I would like you to look at that table up at the top of the page and tell me, do you think that's a function or not? So we're looking for something that's going to break the rule. Do you see the same input being represented more than once? See the same input? I do too. Are you queuing on the -8 and the -8 here? Now, is it breaking the rule? Is the same input giving us different outputs? Nope. So this is okay. This is a function. Okay. Can you guys show me on your thumb meters, if I give you a table right now, do you feel confident that you could tell whether it was a function or not? Oh, you guys are awesome. You guys did awesome today. Okay, I'm going to show you one more thing, and that's how to tell whether something's a function on the graph. Okay, and this will go really quickly if you guys will pay attention. To figure it out on a graph, we do this thing called a vertical line test. And I'm going to write that down here. All right. And I'm going to show you guys some examples of things that pass the vertical line test and things that fail the vertical line test. All right, so here is a wacky looking graph. Let me show you how the vertical line test works. A couple of people are still writing, so I want to pause because this is important. All right, can I get everybody's attention up on the screen? Okay, so I'm going to take a vertical line. I'm just using a paper clip here. I'm going to take a vertical line and I'm going to move it across my function. Now, right here where my vertical line is, how many places is that vertical line intersecting with my function? How many places do you see it crossing the function? I see it crossing the function one place. Do you see it? Do you see the place where those two things are crossing right there? How many places is it intersecting my function right here? Just one? I'll tell you what, as I move across here, can you tell me if we ever get to a point where that vertical line is touching my function in more than one place? Tell me to stop if you see where my vertical line's touching it in more than one place. Anywhere on there? Nope. All right, then this is a pass. That passes the vertical line test. All right, let's try another one. I just drew kind of an S-shaped graph. All right, let's do this again. So same rules. I'm going to sweep my vertical line across the function, And if I get to a point where that vertical line's touching the function in more than one place, touching the graph in more than one place, you guys stop me, okay? So we're good? Just one spot? Just one spot? Problem here? How many places is my vertical line touching the function right here? I'm counting, right at this point, I'd say 1, 2. And then if I come over here, I'm seeing 3. Are you seeing 3 here? 1, 2, 3 places? That's a fail. This is not a function. Failed the vertical line test. So the vertical line test tells you if a graph is a function. So let's go back up to the top. And now this one's kind of weird, so we just have to focus on the dots, okay? So if I do a vertical line here, is it touching more than one dot? Nope. Here? Nope. Here? Nope. Here? Nope. Here? I think we passed. We passed, so this is a function. How about this cool spiral one? Is that going to pass my vertical line test? No, it's going to fail. Go ahead and draw yourself a vertical line and show, oh, right there and right there. Fail. This is not a function. Ooh, this is a fun graph. You're going to learn all about these in pre-calculus in a few years. This is a sine graph. How about here? Is that going to pass a vertical line test? Yeah, it's only ever touching in one place, so that is a function. All right, and you know what? Down at the bottom when we were doing our notes, we should probably show why this fails. Go ahead and draw that vertical line and circle the fact that we've got more than one spot. That's what causes that fail. All right, thumb meter once again. How many of you feel confident? How confident do you feel on being able to do a vertical line test to test if a graph is a function? You guys are awesome. All right, that's our work for today. Let me get you your assignment. You can get started on that. If you've got any questions over anything we talked about, I'll be around to answer those.